Hi. Today I will be speaking with Professor Bill Zoller, a leading atmospheric chemist known for his groundbreaking work in air chemistry, environmental science, volcanic science, and his investigation of the Chernobyl disaster for the United Nations. Dr. Zoller's dedication to research and education has made a lasting impact on both science and public awareness. It's good to be here with you. Um, Thank you for sitting down with me. Um, my first question to ask you would be, how do you define success?
I define success as doing something that other people have tried to do and not been able to, and that you do it and then communicate your findings to other people. I think it's very important that if you do something unique or you do something noteworthy, you should be able to get it out to other people so they can understand it. And that makes it meaningful to them. Otherwise, it's just for your own gratitude, and that's not right. You want to help our society and people in general. At least that's my belief of success.
Right. So financial success isn't really your kind of definition.
Financial success is not. I've never been interested in money or getting money, except for what you need.
Right.
And that means you need to have something to eat, something to drive around, or to go places.
Mhm.
And other than that, no. I've just
Gotcha.
never been a person that wanted lots of money.
Okay. Um, I wanted to ask, where did some of your inspirations to become a professor come from?
Well, I started when I was an undergraduate student at the University of Alaska. I had in high school, I was never studying. All I did is hunt and fish, and I couldn't care less about studying. My father wanted me to go to college and get a college degree, so I applied to the University of Alaska, University of Washington, Oregon. Got turned down everywhere I applied, and finally, the head of the chemistry department from the University of Alaska was speaking in my chemistry class, which I put off till I was a senior, and he asked us to come to the University of Alaska and study chemistry. I told him if he could get me into the University of Alaska, I would be a chemistry major. So, but I'd been turned down already by the University of Alaska. So he went back and looked at my application, and he told me that my father and I had to write a letter to the University of Alaska indicating that I knew and he knew that we would be on probation, that I would be on probation, and I had one semester to get at least a C average. If not, I would leave immediately. And so we wrote the letter and sent it up there, and I got a provisional acceptance to the university based on what I would do the first semester. Well, when I got to Fairbanks, all I did was study the first semester, and I took 7 classes instead of the 5 they suggested because I wanted to major in chemistry, physics, and wildlife management. Why? Because I cared about wildlife management and wildlife, and hunting and fishing, and because he got me in the head of the chemistry department, Doc Wilson, so I had to study chemistry, and I had a B in physics in high school, my only B, and the only B I got in high school. And so I figured those would be my 3 majors. So I started a triple major. And I was amazed when I really studied, I could do it. And when I went home at Christmas, I had 7 A's. I'd never gotten an A before in my life.
Oh, wow.
And I impressed my father. He was very happy, but he didn't have enough money to pay for my second semester. And I had been working with Doc Wilson in the stockroom, unpackaging shipments of chemicals and putting them up on the stockroom shelves and noting them in the logbook. And so I had made a little money that way to help. And Doc Wilson said I could work on the spring semester as well. So I had at least a job to help pay for things, and that would pay for my schooling. So I worked my way through essentially undergraduate school and studied very hard. And at the end of my first year, a new institute had just started, the Institute of Marine Science, and they wanted to hire a lab technician, and Doc Wilson suggested me. So I got an interview with the head of it and told him about myself, and so he hired me as a lab technician. And they had a senior person in the lab already who was I guess she was a postgraduate but had no real degree. She had just taken a lot of classes, and they put her as kind of the head over the lab, and so I was her assistant. Well, it turned out I knew more than she did about setting up the lab and chemicals and making solutions. So essentially, I ran the lab and set it all up, and she kind of assisted me. But we ended up working together quite easily, and I ended up working with the Institute of Marine Science for the next 3.5 years at the university, and that ended up paying for my education. And they paid me more than Doc Wilson was paying in the chemistry department, so that was nice. And I also had access to their equipment. They were much better equipped than the chemistry department. So I was actually doing measurements on a mass spectrometer. Chemistry department didn't have one. They had multiple gas chromatographs. I learned how to run those, liquid chromatographs, and many other instruments that were needed in doing chemical measurements. And I got training from those by the PhD scientists in the Institute. So I learned from people who knew how to use the instruments, and that was a very good way instead of learning from a book. And so I had an extra education that way that helped me an awful lot when I got to working with my classes in the chemistry department. One example of that, when I took analytical chemistry, we were supposed to use some measurements and some very old methods of gravimetric analysis, and instead I ran the samples on a mass spectrometer and got much better numbers, far more accurate. And in fact, I had to dull down my accuracy because I was way beyond what they thought I could do. But I was essentially counting single atoms and doing very, very sophisticated analysis on very simple samples. But that helped me get very good grades. And I ended up going through, and at the end of 3.5 years, the Institute of Marine Science was given a brand new oceanographic boat, and it was in Hawaii. And we had to bring it back to Alaska. And they asked me if I could graduate by the end of the fall quarter or fall semester, then I could go on that cruise, and they would give me a week's vacation in Hawaii. Well, this is Fairbanks, Alaska, and it was 70 below zero. And a week in Hawaii sounded awful good at 70 below zero. So I worked hard to graduate, and it turned out I had taken all the chemistry classes. I still needed one more in physics and 2 more in wildlife management. So I dropped those 2 as majors and just majored in chemistry. And I graduated in 3.5 years. And then got on right after Christmas. I was given an airplane ticket to fly to Hawaii and given a week's vacation. And as normal with somebody from Alaska going to Hawaii, I didn't know about suntan lotion. So I ended up getting really barbecued. And so by the time I got on the boat, I was essentially red all over and kind of very tender while walking.
Wow.
But the cruise was a very miserable cruise. And I had been interested in oceanography and maybe become an oceanographer, but after that cruise, no, I don't want oceanography. So I stuck with chemistry. But it was supposed to be a 5-week cruise. It turned out to be a 5-month cruise because we ran into 3 typhoons. They drove us actually halfway back between Hawaii and Japan. And we had to recover from that. And we didn't have enough fuel on board to make it to San Francisco. So they had to airdrop fuel bladders to us out in the mid-Pacific Ocean. And we had to tow those in and then pump the fuel into the tanks of our boat so we could make it to San Francisco. But we did make it in there with 2 refueling stops and made it to San Francisco, and got a few days there to try to rest up and get going again. And it was very interesting to do that and see land again, because being on that little seasick boat, we didn't eat hardly at all, whatever you could eat, because the cook couldn't keep water in a pan to boil or anything like that. It was just seasick. The boat was rolling 45 degrees on one side and 45 degrees on the other side, and the time period between one side to the other was 15 seconds. I once went from the top bunk on one side to the top bunk on the other side without ever touching the floor. I was just rolling over in bed. and I got flipped over. But it was a rough seasick cruise, and I decided I didn't want to be an oceanographer. So I'll be going back to being a chemist.
That's amazing.
And when I got back to Fairbanks, the year before, people had come up there from MIT to study ice fog, and I had worked with them in 70 below zeros in Fairbanks. And the person that came up there was a professor named Jack Winchester from the geology department at MIT, and one of the graduate students was a guy named Bob Deuce. And he had worked with Jack Winchester, and Bob was a graduate student at MIT. And while we were working, he seemed to be pretty impressed with my abilities, and not only in chemistry, but in handling myself in Alaska. And that was no problem. I was used to Alaska because I was raised there. But he talked me into going to graduate school at MIT and working with Jack Winchester. Well, I went there and drove down the Alcan Highway by myself and got to MIT. And remember, I'm an Alaskan. And so I had all my guns and ammunition in my van. Well, it turned out people at MIT weren't used to people with hunting rifles and shotguns and all this kind of stuff and lots of ammunition. I reloaded my own ammunition. So at MIT, I asked them where the gun room was, and they said they didn't have a gun room. You can't have guns. And I wanted to know where I should put my guns. And you have guns? You can't have those here. Well, I got arrested by the police and Cambridge police, and they sent me over to the Boston Police Department and spent the night in jail. The next morning, the chief of police took me to his house for breakfast and apologized to me for never having me arrested, and said that he was fixing me up a gun room in the police department where I could put all my guns and reloading equipment. And I kept it there the rest of my time in Boston. And I went shooting with the police officers and showed them how to reload ammunition. And we got along great. I was actually given a police badge I could use to get in the building. But if I ever showed it anywhere else, I would be arrested for impersonating an officer. I never showed it outside of the building.
Of course.
But it was a good introduction to me to the fact that the East Coast and people in the Southern 48 don't know about guns or ammunition or hunting or anything like that as compared to what we knew in Alaska. It's standard practice for all of us to be able to reload ammunition and shoot a gun, and I was very good with it. Right. And that was my start into that. But because of the Bob Deuce getting me in to study with Jack Winchester, when I got to Boston at MIT, I found out Jack Winchester was fired. He didn't get tenure. And so I was wondering, what am I going to do now? And Jack said he could probably get me in at the nuclear chemistry group because he had worked with them heavily and they were short students. So he took me over and introduced me to a professor named Charles Coryell. And that was the start of really me becoming who I am. Charles Coryell was a brilliant man. He'd worked on the Manhattan Project, and he was one of the people that developed the atomic bomb. And I heard more stories from him about the development of the atomic bomb and all the people involved with it. And because he was such an important person, he introduced me to lots of very, very famous people I would have never met otherwise. For example, Linus Pauling. I got to know him quite well. And I actually drove Linus and Charles through New Hampshire and Vermont 2 summers. Well, he gave money to small colleges up there to help support them. And they did a tour every summer to see what their money was being spent on. And I got to be their driver. And that was really impressive to me because they would have banquets at each of these little universities to show respect to these gentlemen. And I was asked to be at the banquet with them. Well, I didn't have a suit, so Charles brought me a suit and taught me how to tie a tie and everything. So I ended up sitting between a 2-time Nobel Prize winner and a man who had been on the Manhattan Project at these dinners. And it was wonderful because I was treated as one of them. And this was neat for a young man growing up. And so it was just a wonderful experience for me. And that really convinced me that I wanted to be in science and do research. And that was just wonderful. And I really got that through MIT, and especially with Charles Coryell and the people I worked with. I officially didn't work with Charles Coriel. I worked with another professor there who had never been able to have a graduate student graduate. They all quit him.
Oh, wow.
And his name was Glenn Gordon. So I was told I had to work for Glenn Gordon. I wasn't given a choice in the matter. So I said, okay, fine, I'll do that. And I realized why students didn't want to work for Glenn Gordon. He was a graduate of Berkeley University. And in Berkeley, the graduate students there didn't work in the laboratory or do the science. They had technicians do all that. They sat in an office and drank coffee all day.
Oh.
And they just didn't know how to work in a laboratory. Glenn Gordon had never really been in a laboratory or done any work, never done an experiment. He always had technicians do the experiments, and he had the results, and he would write them up. That's the way they got their PhDs at Berkeley. But they didn't know how to do anything. And so he didn't know how to tell me to do these things, so I had to go to Charles always, ask him how to do it, and he would give me a good idea or tell me, or have me work with one of the other students to show me how to use the equipment and all that. Because the guy I was working with, Glenn Gordon, he didn't know how to turn a multi-channel analyzer on, how to turn a Geiger counter on. He knew nothing. It was totally useless. But anyway, I did the work for him, and thanks to Charles, I learned so much from other people as well. And I actually became an operator on the nuclear reactor because I wanted to do my work at night, because we didn't have that much equipment, and the other graduate students wanted to use it during the day, but they didn't want to be there at night because some of them were married and others had girlfriends, and so they had other things on their agenda for the evening. Well, I would usually sleep in till noon, come in and talk with professors in the afternoon and other students, and then when everybody else went home, I started working. I worked till 5 in the morning.
Wow.
And doing that, and since I had need to run the nuclear reactor, I had to become an operator on the nuclear reactor and run it. And since I was handling radiation, I had to have a radiation safety officer assigned to me. His entire job was just to follow me around and keep me safe. So he worked the same shift I worked. And his name was Dominic DiMartino. And we worked very well together. And he was a very, very great person as far as I was concerned. Because when I wanted to run samples, somebody had to be on the reactor operator bench. I was supposed to be a licensed operator. Well, I was a licensed operator, but Dominic wasn't. But I had to run my samples. So I had him sit down there, and we had a walkie-talkie. If something went wrong, he could call me, and I would tell him what to do. And then I would go upstairs and run my samples on the reactor in the lab and count them. And he would sit down at the desk down there, not knowing what to do, but call me if there's something happened. And nothing really happened during the 3 years we worked together. But that really made a huge difference in my life. By the time I graduated from MIT, I actually had 12 papers published already and another 7 in press.
Wow.
For a graduate student, that was a record. I don't think anyone's ever beat that at MIT. But when I started then, graduated from MIT in 1969, I was offered a postdoc in Hawaii. And after that, Glenn Gordon didn't get tenure either. So the nuclear division was told they were going to close down when Charles died. And Charles managed to arrange a professorship for myself, Glenn Gordon, and another young professor there. And we were all given professorships at the University of Maryland who wanted to start a nuclear group. So we did that and moved down there. And the group we had actually became a very, very well-known and very productive group. I was there for 15 years at the University of Maryland. And after those 15 years, I had published 150 research papers, graduated 45 PhD and master's students, as well as brought in about $10 million worth of funding. Now, a lot of that writing of proposals for the funding, Glenn Gordon was a very good writer, so he wrote the proposals. I just told him what we wanted to do. And then he would write the proposal, and we would get funded. And one of the first projects I had was this fellow Bob Deuce had talked me into trying to do something with him in a postdoc out when I went out to Hawaii before I took my professorship. And that was to write a proposal to go down the geographic South Pole in Antarctica and do air chemistry. No one had ever measured the chemistry of particles in the atmosphere at the South Pole, what was in the air and where it came from. So we decided to do that. And I've always thought that it was kind of stupid to go to the cleanest place on earth and start your work there. But that's what we did. And we had to do it very well because we wouldn't have been outfunded. Well, as it was, we ended up getting funding from the National Science Foundation for 10 years of research in Antarctica. I only went there 4 times. That was enough. After that, we just had other people collect the samples for us and we analyzed them. But we ended up setting the records for the lowest level of contamination on any place on the planet's surface. If you look at a clean day up here in Seattle, when it's nice and bright, shiny skies, and there's no obvious pollution or smog in the air, compare that to South Pole. The South Pole is 1,000,000 times cleaner. That's saying something. It's very, very clean.
Wow.
Usually we talk about a clean atmosphere up here in the area around Washington State as being around 100,000 to maybe 1,000,000 particles per cubic centimeter in the atmosphere. These are called condensation nuclei. They're very small particles, most of them only a few atoms. When we get to the South Pole, there's less than 1 per cubic meter.
Wow.
It's less than actually about 1/10 of 1 per cubic meter. 1 per every 10 cubic meters. It's that clean. It's amazing. 1,000,000 times cleaner than on a clean day in the Seattle area. And I'm talking not Seattle area, the town. No, this is out in Woodinville where I live, which is 25 miles out. And this is what I call clean compared to Seattle. And South Pole is 1,000,000 times cleaner than that.
Wow.
I'm sorry I went on so
No,
long.
you're okay. This is exactly what we want. You talked a little bit about your upbringing in Alaska. I kind of wanted to ask, because I have to ask about what kind of role education played in your success, and obviously it's a big one. But I did want to talk about kind of obviously there's a work ethic that comes from growing up in Alaska. A go-getter's attitude that I think a lot of other people in other states maybe wouldn't have to an extent that maybe you do. What kind of, would you say that your kind of go-getter attitude and your work ethic had a bigger or lesser of a role in your success than your education?
I personally think it had the great deal to have with the success I've had, because up there, people in Alaska were really taught by living there to be pretty independent and to be able to handle things no matter what came your way. And that's one of the things that I prided myself in. I could handle whatever it was. And living in Alaska when it's very cold, for example, you're getting at 70 or below zero, you have to be very careful. You'll frost your lungs. And you frost your lungs and you're probably going to die from it.
Yeah.
Or at least fairly early in your life. So you have to learn to survive. And so survival is a very important part. And in particular, I used to spend a lot of time outdoors and in the wild when we were trapping or fishing or hunting. And so being able to survive on your own and handle things was important. How to build a lean-to, how to get water out of the snow in the winter without having problems from it. And all of these things in living up there made you much more self-independent and aware of what's going on. And that all helped me a great deal in my research because it made me more sensitive to what was happening and what was going on in the laboratory and with experiments, because I was used to having to look for detail.
Wow.
Otherwise, I wouldn't be able to survive. And so survival in an area like Alaska, and that will help you learn how to look and see things differently than most people do. And I'm very blessed because of that, because that's helped me in all of my science as I've done things. In particular, our first attempt at doing research was at the geographic South Pole. As I mentioned, it's very, very clean down there. Well, it's also very cold.
Yeah.
And
Just like Alaska.
my
But
first
colder.
trip down there, what did I take to do our samples between our filter paper we were going to collect the particles on and the pump that would pull the air through them? We used gum rubber tubing. Well, guess what happens to gum rubber tubing at 40 or 50 below zero? It becomes so stiff that if you touch it, it'll break.
Oh, wow.
And so did that work out well? No, it didn't. It was a total disaster. And so after our first trip down there, we learned to do things better. And by the second and third and fourth trips down, we were getting very, very good results. And our final trip down there was very proud because of our innovative research in that. We designed and built a clean air facility. It was called a CAF. And it was a building that was on stilts. And it was stilts were frozen into the snow. And it was about 20 feet up in the air. And that way wind blowing snow would just drift under it instead of building up on top of it. Because most buildings in Antarctica get buried by the snow. And this would just let us have the wind blow the snow right underneath. And when it piled up a little bit underneath, we just jacked it up higher on these stilts. And we were able to use it for 20 years. Now, usually a building in Antarctica, they only use for 5 or 6 years. And then it's essentially covered and going to be broken down by the weight of the snow on it. We just kept jacking it up higher. They ended up putting the I-beams we had for the legs with holes in them for the pins. We ended up putting new I-beams on top of those. And by the time the building wasn't used anymore, there were 3 I-beams all welded together. And so it was a good 150 feet up above where it was earlier when we first installed it. And we won an award from the National Science Foundation as the best building ever built in the Antarctic, most efficient. I was very pleased to hear last year that the new station built at the South Pole a couple of years ago was all built on stilts like ours. The new station is not one big building, but many small buildings, all on stilts, so they can use them year after year. And I've been told I have 3 things on display in the Smithsonian that I either invented or worked on. One of them is that building, which won an award for most efficient in Antarctica. And that was from the National Science Foundation. And another one was from Erebus crystals we collected on a volcano in Antarctica. They're very unique, and now it's a clay feldspar. I have those in the Smithsonian. And then we did the first Freon measurements, and the recording of the first Freon measurements in Antarctica are also in the Smithsonian.
Wow.
And so I've donated to the Smithsonian 3 things. But it's been an interesting career doing those things. But again, my growing up in Alaska, and I'm sorry to be so wordy on this, really made it possible.
No, that's perfect. I love that. Because there's obviously a big difference between the education side of your career, where you're sitting down maybe at a light and writing down things for hours, and then there's a difference between that and actually going out and doing the science, where you're maybe in a pretty dangerous situation. You got gases you got to be worried about, temperatures you got to be worried about, just your nourishment in general. So I really like your response on that. I wanted to also ask about, I have a question here that basically asks about how you went from an idea of a product, and I'm not going to use a product for your case because I don't think you have like a market product, but I do want to ask how your kind of process from going from idea to an execution, what your kind of process for that is. And I thought a really good example for you to talk about would be the gas masks that you kind of borderline invented during your volcanic expeditions. I've heard about it many times in our little slideshow get-togethers, but I'd love to hear about it.
Okay. First, I should mention how we got into volcanoes.
Yeah.
In Antarctica, one of the measurements we made showed a big spike of arsenic, and we couldn't understand where it came from. Actually, it was arsenic and selenium. And when we were back in New Zealand, we were talking to people at the base where the South Pole program was based out of the airport in Christchurch, New Zealand. And one of the people said, a volcano had erupted there, Nangaroe volcano on the Big Island. It had erupted, or on South Island had erupted just a few months before. Mm-hmm. I said, maybe that was part of it. So we went to the volcano to study it, and we collected some samples of it and analyzed it, and it was exactly the same fingerprint that we got at the South Pole Station. So that got me interested in volcanoes. So I decided I would like to study those. Mm-hmm. And the way I started out was as would be a very, what we call stupid thing, but I had to learn the hard way. I went to Iceland. There was an eruption on a volcano on the island of Jaime, which is right off the coast of Iceland. And so I went there to study this volcano. Now, it was erupting and it was steaming out there because the lava and everything else is raining and putting steam and fog up, and it was very difficult to see anything. So the people in Iceland took me where the lava was running into the ocean, and I could walk up and sample gases coming off the lava flow. So I took my backpack with my sampling gear and I walked up there, and lo and behold, I walked out in an area and I saw some red lava ahead of me, so I said, oh, I'm getting close to it. Well, all of a sudden, I heard a big crack, and I looked back, and there was red lava all around me. I walked out on a little peninsula extending out over the lava flow, and it broke off with my weight. And it started going downstream in the lava. And you look around, you got lava, red lava all around you, and you're on this little rock. You say, how am I going to get off? Well, it bumped into the side just a few meters down, maybe 100 meters down, and I just jumped off like crazy. And cut my hands up on the lava rock, just scrambling to try to get away from the heat. And I learned my lesson. Don't ever go in a place with a volcano unless you have a good volcanologist with you for safety. And for the other volcanoes I've gone to, and I've gone to 45 in my career, I've always had a geologist with me. And I have two pet geologists. I call them pet geologists because I wouldn't go anywhere unless they went with me. One was Bill Rose, who had been a professor at Michigan Technical University in Upper Michigan, and the other was Tom Casseval, who works for the U.S. Geological Survey. He's currently in charge of the Vancouver Observatory for Mount St. Helens. But I took those two guys, and we actually got funded by the National Science Foundation and NOAA of two large projects to study volcanoes around the world. And we didn't really concentrate on all around the world. Mainly it was going to be where we could get to them. And so we studied volcanoes in Iceland. We studied volcanoes in all around Central America. We went, in fact, to the tip of South America, took a Lockheed Electra airplane down from NCAR and sampled all the volcanoes in Central and South America that were emitting plumes. And looked at all of those. And when I was in Antarctica, I also sidetracked to go up and study Mount Erebus, which was an active volcano. This is where I found the Erebus crystals I mentioned. But Mount Erebus was a 13,000-foot volcano. When Captain Scott went down to go to the South Pole, on the very first person to go to the South Pole, he stopped at Ross Island on the edge of Antarctica and spent a winter there. And during that time, he walked up to the top of Mount Erebus, which was on Ross Island, and Mount Erebus, and he sketched it in his logbook, had a lava lake in it, and you could sit looking down 1,000 feet down into the crater, and you could see the lava coming up on one side of this lake and then circulating around and going down on the other. And he drew that in his little book of his expedition. And I looked at it, and it was exactly like that same thing going on, and that was 70 years later. And it was really interesting to me that he had written that up and studied it back in 1903. And when I was down there in the 1970, it was still doing the same thing, coming up in the same area and going down. So I collected my volcano samples there as well. But no, that really got me into volcanoes. And after my mistake in Iceland, I learned the best way to do it, and that was take a geologist with you so you don't kill yourself. And that was very useful. And so my friends and I went and studied volcanoes all over South America, Central America. And one of them you mentioned about the gas mask was the volcano we ran into in Mexico. That was a very unique volcano. It's, I think, the most deadly volcano I've ever been near. It was called El Chichon. And El Chichon killed 20,000 people, and mostly from poison gas. Why? Because it dumps out 50 metric tons of hydrogen sulfide an hour. And that's a lot of hydrogen sulfide. Now, hydrogen sulfide is as deadly as hydrogen cyanide they use in the gas chamber.
Dang.
And it's a very deadly gas. And if you breathe it in, it ties up your hemoglobin so you can't exchange oxygen and you suffocate. And it will bind to hemoglobin irreversibly and it won't come off. And it's a very deadly gas because of that. Well, El Chichon was pumping out 50 tons a day. We were asked to go and study it by the Mexican government because they were worried it was going to erupt again. We weren't told there was anything coming out of it. And so we went down there with the Lockheed Electra from NCAR to sample it or to study it from the air before we ever went on the ground. And on the air, we realized immediately we were near it that it stunk like rotten eggs. Now that's the hydrogen sulfide. So I was assigned as head scientist on the aircraft, so I told the flight crew all to go to oxygen, and we as the scientists would be in the back having to deal with gas mask or nothing. And with hydrogen sulfide, what's bad about it is once you smell it, it deadens the sensors in your nose and you won't smell it again. And so when you get into higher concentrations of it, you think it's gone. This is why miners in mines, coal mines, used to use canaries in a cage. If they wouldn't smell it and the canary died, they knew they better get out of there. And
yeah, I always hear that saying about the canary.
but this is why miners used canaries in the coal mines, and people didn't know why that was because of hydrogen sulfide. Because once you smell it, your senses in your nose, you won't smell it anymore. You will walk into much higher concentrations without knowing it, and that's what makes it so deadly. And because once you smell a rotten egg smell, it's going to start killing your sensors. And we noticed it on the airplane. We couldn't smell it anymore after a little while, and yet our instruments told us it was just as high, if not higher, than when we first smelled it. And that was very scary when we're up there in the air. I was just glad the flight crew were all on oxygen, so we didn't have to worry about them passing out.
Yeah.
And the rest of us, we seemed to do just fine. We had a little dizziness after the flight, but other than that, we were okay. And that was an interesting experience. But when we came back, I went out to the National Bureau of Standards and told them we wanted to go into a place that was very dangerous and could they help me design something to work in there. And they told me that a gas mask wouldn't take out hydrogen sulfide. I said, well, can we fix one to make it do that? And they said, well, how would you do that? And I said, well, if we take, I guess it would be lead acetate. You take lead acetate and put that on the filter or on the packing, cotton packing in the gas mask. And the lead acetate, when it reacts with the hydrogen sulfide, will make lead sulfide, which is black. And so we cut little strips on the side of these gas mask canisters, and as you pulled in hydrogen sulfide through the bottom, it would turn it black. And when it got up near the top, you would know you had to get rid of that canister, get a new one. So we tested that at the National Bureau of Standards in gas chambers. And the National Bureau of Standards said they wanted us to be able to do that safely before they would okay us to go into a place like that, where you had a lot of hydrogen sulfide. So my students and I practiced it, got good at it, and then we went down to El Chichon volcano and went in it. And we were the first scientists to go in the side of the crater and actually sample the gases coming out of from the crater, as well as we had sampled them from the aircraft and live it through it. And I think that was a very unique experience in how to survive. But again, my Alaska upbringing kicked in to help always come up with an answer. And that, I think, is a key to what I've done in my success as a scientist. And that's why I've been able to go to so many volcanoes and do it safely. I still have all my fingers and feet and everything else. Don't have any hair left, but that's not from acid or the volcano. That's from age. But other than that, I'm now 81 and I'm thankfully relatively healthy, and I've been able to survive all the things I've done and the places I've gone.
Wow, that is so awesome. My next question has to do with kind of the groups of people you would bring on these expeditions. I know about Tom Cassavall and Bill Rose as your volcanologist, but I know you had more people with you on these expeditions. Were they primarily students, How did that selection process usually come about?
Well, we had on the big NSF project that we were sampling volcanoes with airplanes, a fellow name of Bill, or I got to remember here. Stop a minute.
Just keep it going. I'll cut it off.
Got to get his name. He was a professor at where was that?
You can move past it too if you want. It doesn't have to be.
I can't even picture him.
Was
I
his
can't
name,
come
was
up with
his
a
name
name.
Bob?
No, not Bob Ducey. He was from the University of Rhode Island and then the University of Hawaii. No, Jim Friend. Jim Friend from Drexel University in Philadelphia. Jim Friend and we wrote the proposal. Are you recording again? We wrote the proposal to go to study volcanoes and fly all the way to the tip of South America, I mentioned. Well, in that, we had several other investigators on that. And each of these people were chosen because they knew how to do volcanic measurements. Tom Castle-DeWalls was on that project to help us with sulfur measurements. Jim Friend was on there measuring the sulfur himself with the instruments and usually with one or two of his graduate students. We also had a professor from University of Virginia. I can't remember his name right now. And another one from the University of Maryland that worked with me. And I think there were two other people we had. But these were the faculty members that went on it. And each of them would usually bring one or two graduate students. Some of us would actually bring sometimes as many as four. In particular, my group at Maryland usually had donated many more graduate students. Why? Because I had them, and I had already trained them in how to do the measurements, and we had the equipment to put on the airplane. We designed and built it. So my students were running the filters and the gas absorption tubes and all of these things, as well as the gas chromatographs on the aircraft. And so we supplied usually anywhere between 2 and 4 people on the aircraft crew when we went flying, and where the others usually just supplied one graduate student each. But we had quite a crew of us that would go out, and usually there would be up as many as 5 or 6 people from NCAR on the airplane taking care of the mainly instruments on the aircraft and flying it and those kind of things, engineers, and they help the aircraft fly and keep going. And then we had our scientific crew, and usually there were about 15 to 18 scientists and graduate students on board for each of these flights. But we had quite a crew that we had trained, and they all became very proficient in what they were doing on these research missions. But they were all part of the big program we had funded.
Wow. In your opinion, what makes a really great professor?
What makes a great professor is different than a scientist in some ways. A professor, to me, is a person who teaches students. And you teach students 2 things mainly. A subject, mine happened to be nuclear chemistry. And I taught them chemistry and nuclear chemistry. But in addition to that, you have to have people that are going to communicate that science and learn how to do it. And that means to be able to write it up and publish it, or to be able to speak at it at scientific meetings. And so I encourage all of my students to get out and speak as well as write papers on it. And this is why we were so prolific when I was at the University of Maryland. Our group produced something like 200 research papers in, well, actually more like 250 research papers in a total of 15 years. And all of our students got not only published in these research papers, but we're giving talks at scientific meetings and learning how to communicate their findings to other people. This is very important. Many people just think find him and publish him is enough. No, you have to communicate it to people. And at scientific meetings, that's the best way to do it, because people don't always read all the research you publish. And it's better to talk at meetings and get them interested, and then they will go look up your papers and read them to get more detail. But so you have to be able to communicate it, and you have to be able to communicate it in a scientific method as well as just a verbal communication method. And so both of these are very important for students to learn, and I push all of my students to do both. And so we were very prolific in publishing a lot of papers and giving a lot of talks. Mm-hmm. And I thought that was very important for my students to do that. I had learned that as a student at MIT from Charles Coriel. If you can't get the information out, it isn't any good. That was one of his points. You have to get what you find out to other people, otherwise, what good is it? Right. And so that was always one of my key things I held to my students, and I thought that was just so critical. We have to get that information out of what we've done, or it's useless. And so that, I think, is one of the keys of making a graduate student a successful communicator as well as a researcher.
That's a great answer, because it perfectly comes right back around to your definition of success. I mean, you highlight practicality of information, the usefulness of information, and these big papers and research documents that you put out, and their usefulness is really what matters to you in terms of success. It's not necessarily the rewards or awards or the money or even the experience, even though I'm sure the experience was fantastic. My last question has to do with some of Chernobyl, because I talked about it in the introduction, and I honestly have never really heard you talk about it much. So I wanted to know personally about
what happened. Okay, when I was interested in finding out more about other scientists around the world, remember during the Cold War, Russia was blocked off to us. Mm-hmm. And you really didn't know what the Russian scientists were doing about anything. I'd always wanted to go and study volcanoes in Kamchatka in Russia. I'd never been able to, and I never was. I never did get over there. I'm sure there's a hotspot volcano over there too. It's called Beshevnaya, but never sampled it. I've never been allowed to. I've applied to the Russians to get permission to do it. No, their scientists are studying it. They don't need me. But anyway, so I wanted to get over there. Well, with the Cold War going, you couldn't do that. When the Berlin Wall fell, I decided it was time to go over. So I contacted a couple of people, and I was giving a meeting in a scientific meeting I helped organize for NATO in Hamburg, Germany. And a fellow by the name of Vladimir Nazarov from the Dubna laboratory came to this meeting. Mm-hmm. And he asked me if I would come to Dubna. He said, we want to open Dubna up to the west. It's been a closed city. He said there's only nuclear scientists there. That's where their weapons program was built and based. And he said, we're going to open it up for a scientific meeting next year. He invited me to come. So I said, okay. And he said they will pay for my way once I get into Russia. And, to movement inside Russia, they will take care of that. So, okay, fine. And he suggested I come first to Ukraine. He had one of his students that he had graduated there with a dean of science at Kiev University. And so he suggested I go and visit him, and he would bring me into Dubna because he had graduated from Dubna with him, with Vladimir Nazarov. So I met this fellow was named Viktor Pyarkov, and I was given an email to him, so I emailed him, and he emailed me back through his secretary, Marina, that he would be happy to meet me and show me around Kiev and then take me to Dubna. And so my wife and I flew there. Why did I take my wife? Because I don't like to go places I'm going to get confused or upset about without her. She was my strength. Now, what has happened since she died, I don't have that crutch to lean on anymore. But I've really depended on her. She was a fantastic lady. So we went and flew into Kiev. And there was a little man standing there with a little sign, Dr. Zoller, Dr. Zoller. So we got off and met him, and Viktor Pyarkov was about my size, not a big man, but a very, very nice gentleman. And he just says, We have arranged for faculty housing for you to stay at, and you and your wife, and my wife and I are going to invite you to our house for dinner every night, and we'll have breakfast or lunch at our house as well. We didn't eat in any restaurants or any place, mainly because a lot of them were either closed or didn't have food. I didn't realize that until later. But he arranged for us to have and what their faculty housing was is an old hotel. We were given a whole floor, and so several rooms in it. And one was a kitchen, one was a nice bathroom and everything. We never had hot water in it, was only cold water. And it was very rudimentary. And we didn't eat there, we ate always at Victor's house. But we spent a week with him, and he drove us all over Kiev. Now, gasoline was rationed there. They could only get 5 liters a week. He had saved it up for about 6 months to take my wife and I around. And he had an old car, and it was an old sedan, and he drove us all around the Ukraine, showing us farms and villages and this and that. And we visited the reactor at Chernobyl just to look at it and see what was going on. It hadn't blown up at that time, but we visited the area, and he showed us around that. We went around lots of spots in Ukraine. Then we went, and he took us by train over to Dubna. We went into Moscow and transferred from there to a bus up to Dubna. And Dubna at that time was a closed city. When you went into it, you would find that there were emplacements where tanks were blocking the road, and you could see the area where their machine gun nests were set and everything else. And we just drove right through all of that because now it was open for the first time. And we got into the town, and I was the first Westerner to ever visit Dubna. I was the only one at this meeting. All the others were Russian scientists. But we had it, and I gave my paper, and it was interpreted into Russian for them. Anyway, it was a fine meeting, and I had an interpreter to interpret their Russian into English for me so I could understand what they were saying, because they gave all their papers in Russian, and the interpreter sat with me and told me what they're saying. But it was an interesting meeting, and then I was asked to come back the next year. Well, the next year they had, I think, 5 or 6 Western scientists there. And I was the only one from America. But we had a nice meeting again. I gave my paper, and we did that for 4 years running. I went to meetings there at Dubna. Well, in the process of that, we found that Vladimir Nazarov, who was called the father of the Russian atomic bomb, had cancer very bad. And I brought him some drugs from our university hospital that were supposed to help, and they kept him alive for an extra year. But eventually, he did succumb to his cancer and die. Before that, though, my wife and I managed to get him and his wife to accept Jesus Christ. And we're very proud of that. Victor came to me one day, and Vladimir Nazarov came to me, and through the interpreter, he says, "What makes you so strong and able to do these things?" And I told him it's my belief in Jesus Christ. I'm not worried about what I have in the future because I know what's going to happen. And he didn't know about that, so I had to give him the story about Jesus. And he really liked it. He would he ended up finding a Russian Bible that was in Russian so he could read it. Actually, he didn't find it. I brought it for him from America. I got him a Russian Bible in Russian so he could read it. Anyway, he wanted to accept Jesus, so he and his wife and my wife and I, we baptized him into Jesus.
Wow.
Now, it wasn't a full submersion, it was just a little tap of water. But we wanted them to.
Something.
No, there was at least a motion that they wanted to accept Jesus as their Lord. And I thought that was something.
Yeah.
So we got the father of the Russian atomic bomb to be baptized into Jesus. But that got us in there. And then a year later, Dubna, or not Dubna, but Chernobyl blew up. And since I had been there and we'd known people over there, I was immediately asked by the United Nations to go over and visit the Chernobyl disaster and see what I could from it. So I was sent over there by the United Nations. Now that was interesting. I've never traveled with a diplomatic passport before, but we had a diplomatic passport given to us by the United Nations. And people over there had asked, that we had known, had asked if we could bring some Bibles. Well, you can't bring Bibles into Russia. They go through your baggage, and any Bible, they take it. We'd known that because my wife always carried a Bible, and they took hers.
Every time.
Every time. And she lost it. Well, so I had diplomatic passport. So we said, what the heck? Let's just load a Foot Locker up with Bibles. So we did. Paper-bound Bibles, and we got a whole Foot Locker full of them. And we took it to see what would happen. And there were people over there, Christians that we'd known, that were asking for Bibles. So we got a bunch of them that way. We got a whole Foot Locker in. And we went over there, and we went through customs in Moscow. They looked at our diplomatic passports, and they just, hands off. Our baggage went right through without opening. So when we got outside, and the people there were waiting to take us out, and they grabbed the Foot Locker of Bibles and disappeared with it. Very happy, but we did get some good times in that.
No Bible smuggling.
Yeah,
That's awesome.
but it was the only time I've traveled diplomatic passport. But it was interesting for that purpose. But they couldn't go through our luggage if you had one. But it was interesting, and when we got over there, the Russian people in charge took me to the Chernobyl area and spent a whole day. They had me just driving around in Pripyat, the town that was there, looking at what was left of the town and what happened, and told me, oh, the radiation levels are very low. It's nothing to worry about. Well, I carried my own film badges because I don't ever trust anybody when it comes to radiation. And during that few hours we were there, I picked up a year's dose in radiation.
Damn.
So them saying it was perfectly safe is a total lie. Anyway, when we came to going in the sarcophagus, we were shown around, and funny because our driver had always been right there with the car and just watching us. When it came to the sarcophagus, he came up and started speaking in Russian to the interpreter and Victor, who was with us the whole time. And we found out from Victor, he says he is KGB. He's a colonel in the KGB, and we are not going in the sarcophagus, and I am to leave right now and get out of Russia. I'm to leave on a plane that evening and with my wife and be gone.
Yeah.
The sarcophagus is safe. You report that back. And so we were told to report that. So the first thing I did when I got back was to call up the UN, and I said they wouldn't let us get in the sarcophagus. They said they were supposed to. I know, but they wouldn't. I told them what happened, and they said, fine, we are going to put it's a burden that no or science or money for Chernobyl would be given them unless they open up. And anyway, they blacklisted them. The Russian government.
They were hiding something. They were hiding how dangerous.
Oh yeah, they didn't want us to go in there because it was such a mess.
Yeah.
And they didn't want to admit it. And so they just, and so the UN put them on a blacklist that no support or anything for Chernobyl would be given until they showed true honesty. And as far as I'm concerned, they never did.
Wow.
I don't know what's happened since then. I've stayed away from it. But it was an interesting experience.
Dang.
And personally, I don't think I ever want to go back to Russia.
Yeah, especially now, for sure. Wow. I think that's where we call it there. That was really awesome. So happy you got to do this. Thank you so much.
You're welcome. I'm very happy to do it.
Yeah, absolutely. We'll probably edit it just a little bit, but most of this is going to stay in. You did a wonderful job. So
Well,
really,
you
really
do what you wish with it. I'm very happy if I can help you.
Yeah, absolutely. Thank you so much.
Okay.